Magnets are literal voodoo. You're telling me you can put this red and blue lump of metal next to another lump of metal and it literally learns to use the force? Like, what? Well, it's actually pretty simple. Magnets, like everything else, are made up of atoms. And atoms are made of protons, neutrons, and electrons. Protons are kinda cool, but we don't really care about them. Neutrons are just useless, and electrons are literally the point of this video. Since electrons are charged, moving them creates a magnetic field. The issue is, they don't really move. You know that analogy about electrons orbiting the nucleus, like planets around a star? Yeah, it's wrong. They kinda just exist, somewhere in a cloud around the nucleus. Probably. That's a whole other video. Anyways, they don't really move. So how the hell do we get magnets? Well, electrons have a property called spin, but they don't actually spin, we just call it that because they behave like they would if they were spinning, even though they're not, because that's not confusing at all. An electron can be upspin or downspin, and its spin causes it to act like a tiny magnet. Now, hold on. I just told you electrons are tiny magnets, but doesn't every element contain electrons? So why isn't everything magnetic? Well, hold your horses. You know those clouds we spoke about earlier? Each one can only hold one up electron and one down electron. If a cloud has its two electrons, they cancel out and it becomes useless to us. We really care about the clouds with just one electron. These don't cancel out and the atoms become tiny magnets. Oh, and from now on, atoms look like this because that is just weird. But there's still another problem. Look at this periodic table. Which metals are magnetic? These three. And technically these ones at low temperatures, but that gets weird, so we'll stick to these. Now let's add the number of unpaired electrons. All three have them, but so do all of these elements, so why are they different? Well, in most elements, even if the atom is a tiny magnet, all of the atoms will be facing in random directions, so they cancel out. But iron, nickel, and cobalt are special. Their atoms can talk to each other and line up all of their little arrows, creating a bigger magnet, which is cool, but it doesn't explain why they stick to my fridge. So it's time to bring out the poles. Each magnet has two, north and south. Magnetic field lines go out of the north pole into the south pole. Other atoms in this magnetic field will align their arrows to the field lines, or at least try to. That means if you have a lump of iron and place it here, its atoms will align to the magnetic field. If you look here, the field lines go into the iron, kinda like a south pole, and here they come out, kinda like a north pole. Congrats, you've made a temporary magnet. These two attract, and now your magnet is stuck to your fridge. If you don't believe me, try it yourself. Get a magnet and some paper clips and stick the first paper clip straight to the magnet. Because the arrows in the paper clip start lining up, it now also acts as a magnet and you can stick the next one straight to this one. Pretty cool. Also, this video is like 30 seconds too short, so I'll teach you about electromagnets. Real quick. Run a current through a wire and a magnetic field appears around it. Coil that wire and those magnetic fields stack. Add an iron core and done. Turn the current on and the magnetic field from the wire causes the arrows in the core to line up and you get a magnet. Add even more current or even more coils to make it stronger. Turn the current off, the arrows randomize, and your magnet disappears. That's literally it. I'd like to remind you that neutrons are useless and the electrons told you to subscribe or they'll magnetize your brain.